Distinguish among input, output, and computer memory. Input. Input refers to the data or information that is entered into a computer system from external sources. It can take various forms, such as text, numbers, images, audio, or video. Input devices, such as keyboards, mice, touchscreens, scanners, and microphones, are used to capture and transfer this data into the computer system for processing. The purpose of input is to provide the computer with the necessary information to perform tasks or operations. Output. Output refers to the processed or transformed information that is produced by a computer system and presented to the user or transferred to external devices. It can take different forms, such as text, images, audio, or video. Output devices, such as monitors, printers, speakers, and projectors, are used to display or transmit this information in a human-readable or machine-readable format. The purpose of output is to convey the results, outcomes, or responses generated by the computer system. Computer memory. Computer memory, often referred to as primary or main memory, is a vital component of a computer system that stores data and instructions that the processor actively uses during program execution. It can be viewed as a workspace where data is temporarily stored while being processed. Computer memory is categorized into two main types. RAM. Random access memory. RAM is a volatile memory that provides temporary storage for data and instructions that are actively being used by the computer's processor. It allows for quick access and retrieval of information, but its contents are lost when the computer is powered off. ROM, read-only memory. ROM is a non-volatile memory that stores permanent or semi-permanent data and instructions. It contains firmware or software instructions that are vital for booting up the computer and initiating the basic system functions. Unlike RAM, the data stored in ROM is not lost when the computer is powered off. Explain arithmetic logic unit (ALU). The arithmetic logic unit, ALU, is a crucial component of a computer's central processing unit, CPU. It is responsible for performing arithmetic and logical operations on binary data. The ALU performs calculations and manipulations on data stored in the computer's registers, which are small, high-speed storage units within the CPU. The ALU consists of combinational logic circuits that execute various operations based on the control signals received from the CPU. It typically performs three main types of operations. 1. Arithmetic operations. The ALU can perform basic arithmetic operations, such as addition, subtraction, multiplication, and division. These operations are carried out by performing binary arithmetic on the data stored in the registers. The ALU can handle both signed, positive and negative, and unsigned, positive-only, numbers. 2. Logical operations. The ALU also performs logical operations on binary data. These operations include logical AND, logical OR, logical XOR, exclusive OR, and logical NOT. Logical operations are often used in conjunction with arithmetic operations to perform comparisons or make decisions based on the values stored in the registers. 3. Shift and rotate operations. The ALU can perform shift and rotate operations on binary data. Shifting involves moving the bits of a binary number to the left or right, while rotating involves circularly shifting the bits. These operations are used for various purposes, such as multiplication or division by powers of 2, extracting or inserting specific bits, and implementing algorithms. The ALU operates on fixed-size binary numbers, typically 8, 16, 32, or 64 bits, depending on the architecture of the CPU. It performs calculations on these binary numbers using various logic gates, such as AND gates, OR gates, XOR gates, and multiplexers, which are combined to form complex circuits. Discuss control unit. The control unit, CU, is a crucial component of a computer's central processing unit, CPU. It is responsible for coordinating and controlling the operations of the CPU and its various components. The main function of the control unit is to fetch instructions from memory, decode them, and execute them by issuing control signals to other parts of the CPU and the computer system. Here are the key responsibilities and functions of the control unit. 1. Instruction fetch. The control unit fetches instructions from the computer's memory, typically the main memory or cache, and brings them into the CPU. It retrieves the instructions based on the program counter, which keeps track of the address of the next instruction to be fetched. 2. Instruction decoding. After fetching an instruction, the control unit decodes it to determine the operation to be performed and the operands involved. It interprets the binary instructions and determines which control signals need to be generated to execute the instruction. 3. Control signal generation. The control unit generates control signals based on the decoded instruction. These control signals determine the actions to be taken by other components of the CPU, such as the arithmetic logic unit, ALU, registers, and memory. The control signals coordinate the flow of data and control the sequencing of operations within the CPU. 3. Execution control. The control unit directs the execution of instructions by coordinating the activities of other CPU components. It determines the order in which instructions are executed and manages the flow of data between registers, ALU, and memory. It ensures that instructions are executed in the correct sequence to produce the desired results. 5. Branching and control flow. The control unit handles branching instructions that alter the program flow. It determines whether a branch is taken or not, based on the conditions specified in the instruction or the status of flags or registers. The control unit updates the program counter accordingly, allowing the CPU to execute instructions in a non-linear fashion. 6. Exception handling. The control unit is responsible for handling exceptions and interrupts that may occur during program execution. It detects exceptions, such as divide by zero errors or invalid memory access, and initiates the appropriate response, such as interrupting the current execution and transferring control to the exception handling routine. Overall, the control unit acts as the brain of the CPU, coordinating and controlling the execution of instructions. It ensures that instructions are fetched, decoded, and executed in the correct sequence, generating the necessary control signals to regulate the operation of other CPU components. The control unit's role is crucial in achieving the correct and efficient execution of programs on a computer system. Remember to like, share, and subscribe for more computer-related content. Thank you for watching.